This is always a problem that students struggle with. We're going to find a formula for the derivative of the function g of x using the limit definition of the derivative. A lot of students know how the shortcuts work, but we don't know how the limit definition works. Well, literally by definition, g prime of x is defined as a limit as h goes to 0 of g of x plus h minus g of x all over h. We know this bit right here is a difference quotient, average rate of change. We can estimate instantaneous velocity with it, but when we put the limit in front of it, that actually finds us the exact equation for the derivative of the original function. Now off to the side, under my scratch work, I'm going to find g of x plus h. That's going to be 1 over x plus h plus 1. So I'm going to substitute in for the x plus h, and that's why it's there. Now the denominator just simplifies by dropping off the parentheses. So there we have it. G of x is given to us as this function here, so let's substitute it all in. The limit as h goes to 0 of 1 over x plus h plus 1 minus 1 over x plus 1 all over h. Now again, this isn't any longer about calculus. The calculus stopped about right here by knowing that definition. The rest of it is algebra. So you have to combine the numerator and take the reciprocal of the denominator and simplify it all. That's algebra. Now I'm just going to do it within this problem here instead of going off to the side and doing it. But I do notice that the only difference between these two is that h. However, that's a big problem. They're completely different numbers. So you can't just say, oh, if I just add 1 here and here, or add an h on the top and the bottom, it's going to be the same denominator. No, it doesn't work that way. You wish it did, right? But it doesn't. So this is equal to the limit as h goes to 0. Now I have to find the common denominator, and I'll just write over here the common denominator is x plus h and multiplied by x plus h plus 1. I'm sorry, x plus 1 here. Let me try that again. All I want to do is multiply the two together. I just had a right-o there. X plus h plus 1, which is this guy, times x plus 1. That's your common denominator. So that's the guy that's going to end up on the denominator down here. X plus h plus 1 times x plus 1. Don't multiply it out. Here's a good rule of thumb. Whenever you have a denominator that's already factored, don't multiply it out. First of all, it saves you a lot of time, and second of all, it's going to be easier to mess around with written out in factored form. So when I look at this denominator, I notice that it's missing an x plus 1, so I have to multiply the top and bottom by x plus 1. So an x plus 1 is going to go here. Here, the denominator is missing x plus h plus 1, so I have to multiply top and bottom by that. So it's going to be 1 times x plus h plus 1. Dividing by h over 1 is the same thing as multiplying by 1 over h, so I'm going to do that too. There's a lot of things that happen there, so make sure you know what's going on. And let me separate these two things here a little bit for clarity. Now I'm just going to keep doing some algebra. The limit, let me scooch up just a little bit here, okay? The limit as h goes to 0. Now I'm just going to take this calmly. Get rid of the parentheses. So distribute that negative. Minus x minus h minus 1. I'm going to leave the denominator as it is. X plus h plus 1. X plus 1. Then I'm going to multiply the numerator by 1, which leaves it the same. Multiply the denominator by h. And that's what I got going on. Continuing to simplify the numerator. Because I'm not multiplying out the denominator. Don't do it. So in the numerator, the x's go away, and the 1's go away, and I'm left with negative h. See how important that was to distribute that negative there? Because this is negative h on the top. And the denominator is x plus h plus 1, x plus 1 times h. Now, no matter how much you want to, do not multiply out the denominator. Because you can now see that h and h cancel, and I'm left with 1 in the numerator. So limit as h goes to 0 of minus 1 divided by x plus h plus 1 times x plus 1. Now I think if I plug in 0 for h, I get my derivative. So I plug in 0 for h, this guy goes to 0, so I'm left with minus 1 divided by x plus 1 times x plus 1, which can be simplified as minus 1 over x plus 1 squared. Please don't multiply that out. Factor it, leave it. And that's it for this problem.